يلا Noor or Guillaume, you can try to share your screen.
Okay, يلا I will.
Okay, yalla, we're ready to hear you.
You want us to start? We begin?
Yes, start.
Okay, so hi guys. Today Noor and I will be presenting Hyperloop, our project, which is considered to be the future of transportation. Next slide, please, Noor. Just to get an idea about the whole presentation, we will go over Hyperloop, what it is and works, and then about the current state of the technology, who are the major stakeholders and their most recent findings. And then we will touch on the impact of this project, the technical difficulties, safety and regulations. And lastly, we will talk about the future of the technology and the next steps that need to be taken. So just before jumping into Hyperloop, let's have a look over the current transportation problem. So current modes of transportation consume a lot of energy. 62% of the US government energy consumption was for transport only. They are also not fast enough, even airplanes, and they consume and they are they lack sustainability. So basically, those are the problem of the current transportation sector. So it's clear that we need a solution, and this solution is Hyperloop. Next slide, please. So in simple terms, Hyperloop is a high-speed mode of transportation based on magnetic levitation and powered by renewable energy. So the pods or capsule, as you can see, can move in tubes above or underground and can reach a travel speed of 1,200 kilometers.
Okay, so as Guillaume said, Hyperloop is a new concept that has emerged with Elon Musk in 2012 when he first published a technical white paper named Hyperloop Alpha. Hyperloop will carry its passengers in pods or capsules in a partial vacuum steel tube. That way, the two main reasons that slow down normal transportation are minimized, which are the rolling or contact friction and the air friction, which is the aerodynamic drag. This technology is very similar to Brunel's atmospheric railway, which operated between 1847 and 1848. And to put the speeds into perspective, for example, the Los Angeles to San Francisco route, which takes 8 hours by bus, 4 hours by train, 3 hours by plane, will only take 30 minutes via Hyperloop. So how does it work? Hyperloop first will explain the concept of levitation. Levitation is divided into two main categories, which are the magnetic levitation and the air bearings technology. This technique will minimize the rolling or contact friction. In magnetic levitation, we have the electrodynamic suspension, the electromagnetic suspension, and the third technique is air bearings. So first for EGS, it is based on repulsive forces. We have permanent magnets located on the pod that will create, and we have a conducting track. These electromagnets will create a magnetic field that will create eddy currents due to Faraday's law, and this will create a lift force lifting the pod above the track. For EMS, however, it is based on attractive forces. We have electromagnets on the pod and two conducting tracks. Also, the magnetic field will lift the pod and have a distance between the pod and the two tracks, and this distance has to always be monitored. Third is having air bearings, which is, by the way, the technique that was suggested by Elon Musk, and it consists of releasing pressurized air, which will create a cushion on which the pod will be floating. Now, the pod has been lifted, but how does it move initially? The answer is through propulsion. Of course, there are many propulsion techniques in the literature and in research areas. However, the most famous one is the linear induction motor. So we have electromagnets on the pod, which is the primary part, that will create a magnetic field on the guideway, which is the secondary part, that will also generate a propelling force that will move the pod inside the tube. Second, the second kind of friction that has to be mitigated is the air friction or the aerodynamic drag. Ideally, you would have the pod moving in a vacuum environment. However, this is not impossible. So we have to reduce the pressure as much as possible. But if the pressure is very low, and the gap between the capsule and the pod is very small, we will have choked flow. This is known as the Controwitz limit. And to mitigate this, Elon Musk suggested having compressors in front of the air backwards in order not to have this choked flow. Now, also for the design, we have many designs. Every company, every research team can suggest its own design, but here we will present the design that was suggested by Elon Musk in Hyperloop Alpha. So as you can see, we have a reduced frontal area of the capsule, and it will contain 28 passengers per capsule, for example. It can weigh approximately 15,000 kilograms, and it will have a surface area of 1.4 meters squared, excluding the propulsion and the suspension components. It will also require only 100 kilowatt to be driven and 320 Newton drag force. The capsule is intended to cost $1.35 million. Now for the tube, it will be partially evacuated and it will be held by pillars. The tubes are intended to be prefabricated and then installed on the pillars. Then we have solar panels covering surfaces of the tube that will generate power or electricity, power mainly, and this will cost $4.06 billion.
Okay, so Noor talked about the technology and how it works in theory. Now we'll be talking about the current state of Hyperloop. So Hyperloop in 2012 experienced an accelerated growth and gained a lot in popularity because of Elon Musk when he introduced Hyperloop Alpha, which is the first project that was implemented, like the first prototype, and he did not file for a patent. So he made his finding accessible for everyone. And this is when many stakeholders and multiple organizations invested their resources in researching and developing the initial model. So mainly, we have the main stakeholders, Hyperloop TT and Virgin Hyperloop in the US, Zelros and Hart in Europe, and many others. Over the years, many research and testing were conducted. The maximum tested speed was 1019 kilometers per hour. It was reached by KRRI in Korea, and the complete full-scale testing of a Hyperloop model was conducted in 2017 with Virgin Hyperloop. So many concrete projects emerged after that. Mainly, we have the Ohio-Chicago route. We will be talking about it later on. It was conducted by MORPC, and it's a full feasibility study in America. And the Dubai-Abu Dhabi route by Virgin Hyperloop, which is almost ready to be fully implemented. Next slide, please. Just so you can get an idea of how fast the technology is evolving and gaining in popularity, $6 billion is the projected volume of the Hyperloop market in 2026, so in less than 5 years. Please next. Now we will be talking about the impact that Hyperloop will have on society, economy, and environment, both positive and negative impact. And the economic impact, we will also be talking about the implementation of the implementation cost of Hyperloop, because it's an important factor. Please next. We will start with the social impact, since it should be the main concern of any new technology, to see how it would affect directly the society and the people. I'll first explain one concept, which is the alteration in distance perception. So basically, with Hyperloop being introduced into the mode of transportation, we have a huge difference between the time travel using Hyperloop and other modes like airplanes and cars. So now there will be an alteration of the perception of distance. Let's say someone living in Paris can now be closer to a city in Russia by Hyperloop than he is to a city in France, just right next to Paris. So basically, this is how the distance of the perception of distance will change. The second concept is the reduction of travel time. So this is the main advantage of Hyperloop as we talk. And it's clear that it's faster than car and train, but it's also faster than airplanes, not only because of its travel speed, but also because Hyperloop has one main advantage. The stations are designed to be implemented directly inside the cities and in popular area, not like airports where you have to drive, let's say, an hour to get there and an hour to get back. So this is where you lose time. Third, with this reduction in travel time, with this reduction in travel time, people can now live further away from their work and city center. And this will push towards decentralization and towards lowering the population density in some cities. Lastly, one negative impact of Hyperloop is that people will face inequalities based on their location. So people living far from the station of Hyperloop may not fully benefit from it, but they would still pay for it through taxes, etc. So this is one negative impact. Next slide. Now moving on to the economic impact, because any new technology should be economically viable in order to be implemented.
Yeah.
Yes.
Can you try to change your place because the voice is not very clear? When Noor is talking, the voice is much clearer. Can you please try to change your place?
Is it better now?
Yes, better.
Okay. So as I was saying, now we're moving to the economic impact. I'll start with the investment and infrastructure costs. As you can see in the table on the right, the cost of Hyperloop is really huge. So the tubes alone, above or underground, can cost between $37 and $60 million per kilometer. So it's a large number. And stations can cost up to $700 million. So basically, this project is really costly, but it's not incomparable to other transportation projects because it's a transportation. So it's designed to serve countries, a whole country for many years. Now, to talk about the impact on the economy, we have both direct and indirect impact. I'll start with the direct impact. So Hyperloop will increase travel time savings. This is calculated by estimating the shift in ridership volume. So in simple terms, it's estimating how many people will shift from cars and train to Hyperloop. So you'll get a value of the time saved in hours or in time unit. And then we can convert this time unit to dollar unit to quantify it. This basically involves assuming how much the time of people is worth in dollars. The Ohio-Chicago project, the feasibility study, is expected alone to generate $1.6 billion in travel savings. Now, also, since Hyperloop can transport goods and not only people, it will also generate massive freight benefits in the retail market. Capacity is expected to grow by 5 using Hyperloop, simply because retailer can now deliver faster and deliver and cover a wider radius of operations, and therefore they will attract more customers. So in simple terms, faster delivery will create a higher profit margin. The last direct impact is the reduction in operating costs. This is also straightforward. Less energy consumes equal less operating costs. So the Ohio-Chicago project will generate $1.1 billion in savings alone. Also, this is an estimation, of course. In terms of indirect impact, we have a stimulation of the real estate market because people will consider living further away from their job and into areas that were initially not very populated. So this is one aspect. The stimulation of tourism also because travel will be easier, and also an employment growth because implementing a new project which is huge, like Hyperloop, will open up a lot of jobs in multiple sectors. Please, next.
Okay, now last but not least, the environmental impact. So to begin with, it is important to realize that 29% of the US gas emission came from transportation in 2019. So sustainability is indeed an important factor. Hyperloop is here to provide the solutions. So first, Hyperloop uses clean energy, such as solar energy, reducing CO2 emissions in such a way that zero emissions can be achieved by some designs. Second, Hyperloop is energy efficient due to the fact that it is operating in a low pressure environment. As mentioned earlier, the required power is minimal. Third, Hyperloop will contribute to the comfort of people. Hyperloop is in fact noise-free due to the levitation technique. Also, since the pod will flow inside the tubes, weather conditions do not affect the passengers. Also, the low pressure environment will provide comfort for passengers even at high speeds. We only have one environmental drawback, which is the fact that Hyperloop will have to cut down trees and destroy green spaces for the infrastructure to be constructed. This will negatively impact ecosystems. And now we move on to the most important aspect of any new technology, with its safety. First, Hyperloop is intended to be fully automated, so there will be no human error. Also, the tubes will protect the system from weather conditions, such as rain, and the earthquakes, for example, will be resisted by the construction of the pillars. Then the guideway will be on the pillars above ground, eliminating any trespassing risks. And the most advantage aspect is that the chips are short. So in case of any component failure, the pod will be able to continue its journey till the destination point safely. And this journey will be continued by getting power from lithium storage batteries, for example. And in the case of a stranded pod inside a tube, the pods ahead will continue their motion, their journey, and the pods behind will stop. But what if a technical error occurs? Well, the system is intended to operate following the fail-safe principle, meaning that the motion will be stopped in case of fire or depressurization or any cause of danger such as this. Now, what about the regulations? For example, the US Department of Transportation, TUD, which is a trusted agent in Europe for safety, and the European Union Agency for Railway that have already submitted standards. However, further work is called upon. Now, what are the technical difficulties that Hyperloop faces? First, the slow progress. In fact, only 2 companies are making significant advances consistently in the technology, and they are Virgin Hyperloop and Hyperloop TT. Still, these companies did not achieve the promised performance, and this is due to financing. Second, Hyperloop is facing many difficulties on the technical side. Sonic speeds are not met yet, and as can be drawn, it is very costly to ensure safety. Maintenance is also a problem, and it is more costly for Hyperloop than other modes of transportation that are similar. The vacuum tubes have not been realized yet, and the heat losses due to propulsion have not been managed yet.
Okay, so now I'll be talking about the future of the technology, Vision 2050, and what are the required steps to make Hyperloop a reality. Please, next slide, Noor. Okay, so Vision for America by Hyperloop One presents a summary of the major Hyperloop project in America under study right now. And you can see how they cover many states. This figure shows the number of people served from each route and the estimated travel time saved for each project. So this is just a summary. Please, next slide. So to wrap up everything, we saw why and how Hyperloop is really a game changer in the transportation sector. Since one, it's outperforming other transportation mode, but it's also solving the major concern of the 21st century, sustainability. Now, we also saw how Hyperloop is facing many challenges, and we recommend taking the following steps in order to make it a reality. One, which is the most important, stakeholders should share their knowledge and conduct additional research and set standards in order to reach a final and optimal version of the model. Second, those stakeholders should also regroup under one entity or association and actually monitor and start working on the implementation of the project with one and common vision. So this is also important. Step 3, which is the main challenge here, is to gather the funding and capital needed to actually implement the project. And this cannot be done by governments alone because it's high risk, and it cannot be done by private companies alone because of its big scale. So the solution would be to have a private-public partnership, and this would also require accurate financial and revenue models in order to assess the cost and benefit of this project. Lastly, and the last step, and this is after securing the funds, parties involved should design and plan the routes and connection based on multiple factors like the demand, the funding available, in order to identify the optimal route to connect stations in the most efficient way. So that's it. That's it from our side. If you have any question, please go ahead.
Okay, thank you. First, anyone wants to ask questions?
Yes, I have 2 questions actually, if I can.
Yes, what's your name?
Adi.
Yeah, please go for it.
Okay, so my first question is that I was wondering, does it only operate on straight roads or rails, or can it like be implemented in different geographies?
Okay, I will take that question. So, Ghadi, it can operate on various roads, but the more the road is complicated, but can you please mute your mic? في echo. Sorry. Okay, so the more the roads are challenging, the more the physics are challenging. So let's say you have turns or you have strong wind or stuff like that. It will be more difficult to implement Hyperloop. Until now, we did not say that anything is impossible or possible. However, as I said, you have to cut down trees, you have to construct pillars. So it's not like you can build it anywhere, but nothing is impossible. So it will only involve more cost and more difficult physics.
Okay, thank you. And can I ask one more question, Professor?
Yes, sure.
Somewhere in the slides, you also mentioned that like 900,000 jobs will be created. But what I thought is that also some jobs will be destroyed, like anything related to trains, trucks, the operations, drivers, etc. So did this not take into account?
I can take this question, but can you please mute because there's noise? Yes, thanks. So basically the 900 plus thousand, almost 1 million opening new jobs is a net increase in jobs. So it's taking in the study, it's already taken into consideration the job that will be lost from, let's say, cutting trees and other infrastructure that were destroyed to implement the project. But this number is almost negligible compared to the job opening of implementing a transportation mode over a whole country. So it's kind of not really a big number.
Okay, thank you. Other questions? Okay. So thank you for the presentation. I want to ask you first, is this strategy already implemented in some countries?
If you mean as in the technology as itself and used as a transportation, no, not yet. But there is many studies conducted on specific countries with specific routes and implementation costs. So it's like fully prepared to be implemented, but not yet functioning.
And okay, so also in terms of, can I add something? But yeah, in terms of implementation, we have research teams in universities and the companies that I've mentioned that have begun working on prototypes or small-scale Hyperloops, and stuff like that have been implemented. For example, Virgin Hyperloop have achieved the speed of 760 km per hour. And Guillaume cited one in Korea, a Korean company which achieved 1,000 kilometers per hour, but it's not on a human scale, it's only on the small scale, like an experiment.
Okay, so there are still need to do some experiments to make sure of all issues before implementing it?
Yes, not only the issues, yani we don't only have the safety or implementation issues. We have that the physics have not been realized yet. The low pressure is not realized yet. The sonic speed is not realized yet. This does not mean that this is impossible. It is possible, but we did not achieve it yet.
Okay, that was the conditions that are working now. If you said that we achieved already a very high speed, so does it have to be perfect to be implemented, or we can start with, let's say, the model we reached now, and with time it can be the advanced. So you know that, for example, cars, the first car which we started with is not like the cars which we are driving now. So even if it's not complete yet and not all physics achieved, why we, since already it's established, why we don't go for it and start using it?
It's mainly because we have two problems. The first one, as I said earlier, it's the funding of implementing such a project. It's really huge in terms of money and implementation cost. And the second problem is because Hyperloop travels at a very high speed, so any technical error or physics not considered can deal huge damages. So basically, the prototype should be perfect before being implemented.
Okay, okay.
So to summarize, we have financing issues, safety issues, and regulation issues. So not enough interested stakeholders have put the needed regulations for such a technology to be implemented.
Okay. The economical studies performed considered, let's say, a complete study to see if this is what will be the payback period of such system. So what is the time needed to
Yes.
have, yes, nearly what is the time needed to have a balance for the costs?
Basically, the Ohio-Chicago route, which is what we talked about in the economic aspect, is expected to be working for 30 years. So the payback period will be around 27 years and 3 years of pure profit, if you want, after the 27 years. But
Okay, and
operations
already it's a very long payback period. So
yes, exactly. We should keep in mind, it's in transportation sectors. So in many countries, metros and trains have a payback period even longer than that. They used to have one. Yes.
okay, okay. And concerning the physics, can you please just go back to the slides and re-explain them in more detail?
Yes, of course. Okay, so first for the levitation, we have three techniques. So basically the electrodynamic suspension or the electromagnetic suspension are very similar. They operate based on the magnetic levitation aspect. Okay, so you have electromagnets or magnets that are on the pods. I don't know if you can see a cursor or something. I will, okay. Okay, now you can see a pointer, right?
Yes.
Yes, we can see.
Okay, so here are magnets, okay? The electrodynamic works on repulsive forces. When the pod moves, we have a magnetic field that is being generated, and this magnetic field will have an effect on the conducting track. So the track or the guideway will have also magnets on it, and it will be conducting. Okay, and this, due to Faraday's law and due to Lenz's law, will create forces. One that will be lifting the pod and it will move, and another one that also can create some sort of friction. However, many papers and research have been done on this, and the friction or the opposite force that is due to Lenz's law is very, very minimal. EMS, electromagnetic suspension, is also based on magnetic field and magnetic generation and Faraday's law. However, we have two conducting tracts and it will operate on attractive forces. So the pod will be lifted up, and we also have a constant monitoring. So here we have another technique, which is to monitor the distance, and this will make also the motion for the electromagnetic suspension not stable, so it is not preferred. And the third one is having the air bearings, which is the innovation now. Yes.
Thank you. Guillaume, can you
Yes.
explain the third type, please?
Yes, sure. So about air bearings, this is the third levitation technique, which is based on releasing the pressurized air, creating like almost a sort of vacuum, and then the air will be rejected into the tube. I don't know if you can see the. I cannot because Noor is presenting,
It's fine. It's fine.
but
Describe what
basically,
you. Yeah.
yes. So basically, we have like a turbine in front of the pod or the capsule. Air will be entering and will be redirected into the bearings to be driven outside of the pod and limit the friction, basically.
Okay. Okay. Thank you, guys. Any
Thanks
question
to
on
you.
this? Okay, so I will open a new meeting for the questions for exam. Okay.
Okay.
Mm.